Okay, in this video, we're going to talk about retaining rings. So, retaining rings looks like this, where there's a circle, it's like a thin circle, and then there's usually these two holes here. So, these two holes is for you to insert the retaining ring pliers to help you open this little slit here. So, the whole thing will kind of flex open, and this will allow you to um, put it on a shaft or remove it from a shaft. And then there's also different types here that looks like these. So these are like the E style rings. So these just kind of snap on. You have to kind of push it with some force. So it just depends on what type you want. Those are typically a little bit bulkier. These small ones are a little bit um, more slim in their form factor, so that could be nice. And this is really good if you want to retain anything that's within your shaft. So, unlike a shaft collar that's very bulky, this could be a very compact and slim solution to what the shaft collar does for you. So, you can see based on your application, there's different types that you could use. Um, I won't go over all of them, but you could read about it. There's like heavy duty ones. You have certain push on external retaining rings, but I would say the most common ones are these ones that you see up here. So we'll take a look at that one. So typically, the way you would spec these out is you would just look at the shaft diameter you're using, and then some shafts come with the groove diameter here. So based on the groove diameter, you'll know what the inner ID is, and then you could um, machine it as is. So let's actually check. Let's see if we do like shaft with groove. I think you could find some things. I'm assuming it has a lot of that. But yeah, you can see here linear motion shafts with retaining ring grooves. So that would be an example of that. So we could see that this one is 1/4 inch. So if we take a look at this, if we zoom in, you could see there's like a groove length. So typically you could specify this end to groove length. Okay, so this one here, it tells you that this is a 1/4 inch shaft, and then the groove itself is 0.23. So that's the diameter. And you could spec out where you want the actual location to be. So you have the end of groove and the groove to groove length. So this one here has 2. Um, we could just specify something. So maybe we have zero point 0.5, and then you could do like 0.75. And then here, maybe we have 5 inch, something like that. Okay, so you could just specify the different dimensions. Let's download one and check it out. So if I save this and look at it, okay, so you can see that this here is my retaining ring. This one is actually 1.5. Let's change this to our rooftop. And then let's get the corresponding retaining ring. So if we look here at the ring inner ID, this should be 0.23. So you get the next closest one. This is 0.22. So by default, it might be a little bit tight, but once you snap it on, it should get a tighter fit. So you can see here that this is for OD of 1/4. which is what we're looking for, and this is 0.029, and the thickness of this is 0.025. So you can see that there's a little bit of a 0.004 thou gap, so there's a slight room for it to slide back and forth, and that's usually okay. So if I download this, we could check it out. Okay, so I'm gonna put this in my assembly. So we have our shaft, and then this is our retaining ring. So if I mate this and mate it here, you see that. Just gonna mate this to one of the faces. Okay, so you can see there's a small gap, like we were saying earlier, and this little gap just allows, because you don't want a very tight tolerance, you just want it to kind of snap on. And if you cared more about the specific location, then maybe a shaft collar is better for you. But if the exact location is not too important, then you can have something like this. Okay, so in this case, maybe you have two here, for example. So I'm gonna mate this one to. I'm gonna mate this face. Let's see. Gonna mate that face to this face. Okay, so you can see these two holes here, and these two holes you have the pliers to pull it apart to assemble it. And in this case, maybe there's something in between. Maybe you have something rotating. So just for the sake of example, I could make a quick part here. My top plane, and then let's do a plate. Let's make this 0.2. And then inside, let's do a sketch of a circle. I'm not going to care about the location right now. It's 0.25. Extrude cut through all. This plate is actually pretty big, so I'm going to decrease it. Actually, let me just make this a 1 inch. And then let's move our extrude cut hole to somewhere more reasonable, somewhere in the middle. Call this plate with hole. And let's save this in our retaining ring. So if I just put this in here, and if I mate this to the shaft, okay, so you can see here, this is pretty big. I think this mate didn't go through, so let's mate this again. And we can see the distance between this and that is 0.133. So we could go ahead and make this a 0.125 inch plate. So let's just say for some reason, maybe you have some block here that you want to constrain between these two retaining rings, then you can see that this can lock the plate in place. So now this plate won't slide out of the shaft. Okay, so that's one application of using retaining rings. All right, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one.